Welcome everyone, and thank you for joining this session. I'm Jogul Sarwar, and today we're going to talk about some common issues that come up in ETL processes and data warehouses, like data mismatches, where the loaded data doesn't quite match the source, transformation errors that happen when data changes incorrectly during processing, missing data that leads to gaps in reporting, and overall data quality challenges that can affect decision-making. To tackle these problems, we use different types of ETL testing, such as source-to-target validation to ensure data moves correctly, transformation testing to verify changes are accurate, and performance testing to check system efficiency. Throughout this session, I'll guide you through practical examples that show how these testing methods help us catch errors early and make sure the data in your warehouse is accurate, consistent, and trustworthy. This is crucial because reliable data is the backbone of good analytics and business insights. Now let's move forward and take a closer look at the specific ETL issues you might face in your projects. Thank you for being here, and I'm excited to get started. When working with ETL and data warehouse testing, the first step is to clearly identify where the data comes from and what issues might exist within those sources. This ensures that when data is extracted, transformed, and loaded, it remains accurate and consistent throughout the entire process. Common problems we often encounter include data mismatches, missing values, and inconsistencies that can affect the overall quality and reliability of the data. By carefully validating each stage, we maintain data integrity, which is crucial for making sound business decisions and supporting compliance requirements. We'll also look at practical examples using SQL to illustrate how these checks are performed in real scenarios, helping to reinforce the concepts and demonstrate how these testing methods improve enterprise data reliability. This approach not only catches errors early but also builds confidence that the data warehouse reflects true and trustworthy information. Thank you for following along so far. And next, we'll dive deeper into specific ETL testing types and hands-on examples to see these principles in action. In any ETL process, making sure data moves correctly from one system to another is critical because even a small error can lead to wrong decisions down the line. Maintaining data integrity means the information remains accurate and consistent throughout extraction, transformation, and loading, which supports smooth business operations. However, common challenges often arise, like inconsistencies where data doesn't match across sources, duplicates that can skew results, and missing data that creates gaps in analysis. This is where thorough testing comes in. It helps identify these issues early and ensures compliance with data standards. By rigorously validating the ETL processes, testers play a key role in improving overall data reliability, making sure the data we work with is trustworthy and ready for use in reporting and decision-making. Next, we'll dive into the different types of ETL testing and look at some practical scenarios to see how these tests are applied in real projects. When working with ETL processes, several common issues often arise that can impact data quality and reliability. One frequent problem is data truncation, where information is cut off due to field length limits, leading to incomplete records. Missing records can occur if data isn't properly extracted or loaded, and incorrect joins during transformation can cause mismatched or duplicated data. These issues often stem from mismatched data types between source and target systems, or inconsistent formats in the source data, which can confuse the transformation logic. Faulty transformation rules themselves can also introduce errors if they don't handle data correctly. To address these challenges, it's essential to perform regular audits and use automated validation tools that check data accuracy throughout the process. In addition, thorough testing of the ETL workflows helps identify and fix problems early, reducing the risk of errors reaching the final data warehouse. This combination of careful testing and ongoing validation ensures that the data remains accurate and trustworthy for decision-making. Next, we'll explore the different types of ETL testing and how they help maintain data integrity. Data truncation happens when the data being loaded into a table exceeds the maximum length allowed for a column, causing the data to be cut off or shortened. This can lead to incomplete or inaccurate information, which in turn affects reporting and analysis. To catch this issue early, we use SQL queries that check the length of data fields against their defined column sizes. By identifying where truncation occurs, we can fix the problem before it impacts downstream processes. Proactively monitoring for truncation is crucial because it helps maintain data quality and prevents loss of valuable information during extraction, transformation, and loading. This step ensures that our data warehouse remains reliable for business decisions and analytics. Next, we'll explore practical testing techniques that help validate data integrity throughout the ETL cycle. Now that we've looked at specific issues like data truncation, let's focus on the broader challenges around data quality that often arise during ETL processes. These include problems like data mismatches, where the information from source systems doesn't align correctly after transformation, missing data, which can lead to incomplete reports or decisions, and transformation errors, where the logic applied changes the data incorrectly. Addressing these challenges is crucial because poor data quality can undermine the entire data warehouse's reliability. That's why thorough ETL testing is essential. It helps identify and fix these issues early on, ensuring the data we use is accurate and trustworthy. Up next, we'll explore the different types of ETL testing and how they help validate these key areas. Data quality challenges often come down to a few common problems. One is invalid formats, where the data doesn't match the expected pattern. For example, a date entered as text or a phone number missing digits. Missing values are another issue, which happen when fields are left blank or data isn't captured properly, and that can cause gaps in analysis or reporting. Duplicate entries occur when the same record is entered multiple times, which can distort results and cause inefficiencies in processing. Finally, inconsistencies arise when the way data is represented varies between sources, such as different spellings or formats for the same information. These issues can seriously impact the reliability of your data, so identifying and addressing them is key to maintaining data integrity throughout the ETL process. Next, we'll look into the different types of ETL testing that help catch these problems early and ensure data accuracy. When data quality is poor, it creates a ripple effect that impacts many areas of a business. Reports generated from flawed data become inaccurate or misleading, which means decisions made based on this information might not be effective or could even cause harm. This unreliability can also lead to compliance issues, as inaccurate data handling may violate regulations or standards. On the operational side, processes slow down or become less efficient because errors require extra time and resources to identify and correct. Over time, if the data infrastructure continues to suffer from quality problems, it can undermine the overall success and growth of the company. By understanding these impacts, it becomes clear why thorough ETL testing and strong data quality measures are essential to maintain trust in the data and support sound business decisions. Next, we'll explore the different types of ETL testing which help catch these issues early and keep data reliable throughout the workflow. Invalid email formats can cause real problems for communication and marketing efforts because messages may never reach their intended recipients. By using SQL queries to identify emails that don't match valid patterns, we can catch these issues early and improve the overall quality of our data. This kind of email validation is crucial because it helps ensure that contact lists are accurate and reliable, which in turn supports more effective outreach campaigns and reduces bounce rates. When we detect and address invalid emails during the ETL process, it strengthens our data integrity and makes downstream reporting and decision-making more dependable. Next, we'll take a closer look at some specific ETL testing approaches that help validate data accuracy and catch these kinds of errors before they impact the business. Now, Let's turn our attention to entity testing. This type of testing focuses on verifying the accuracy and consistency of individual data entities as they move through the ETL process. It helps identify issues like data mismatches, missing records, or incorrect transformations at the entity level before data gets aggregated or loaded into the warehouse. By validating each entity carefully, testers can catch errors early and ensure the data remains reliable and trustworthy for reporting and analysis. Next, we'll explore some hands-on test scenarios to see how these concepts apply in real-world data environments. Entity testing focuses on making sure that the data entities in your database are structured correctly and free from errors. This means checking that all required fields are filled in and that values meant to be unique don't repeat. It also involves verifying relationships between different entities so the data remains consistent and meaningful. One critical aspect here is referential integrity, which ensures that every linked record has a corresponding counterpart, preventing orphan records that could cause confusion or inaccurate reporting. By validating these elements, entity testing helps maintain high data quality, which is essential for reliable analysis and decision-making. Next, we'll explore how these principles are applied in practical ETL testing scenarios. Primary keys play a crucial role in any database because they uniquely identify each record, ensuring that every entry can be distinguished from others. It's essential that these keys never contain null values, as that would break the uniqueness and compromise the integrity of the data. To maintain reliable and accurate databases, we use SQL queries to detect any records where the primary key is missing or null. Finding these problematic records early allows us to correct them before they cause bigger issues, such as duplicate entries or data mismatches. This kind of check is a key part of ETL testing, helping to prevent errors that could affect reporting or decision-making later on. Next, we'll look at another example of entity testing that focuses on different types of data validation. Referential integrity is all about keeping the relationships between tables in a database consistent and accurate. When this integrity is maintained, it prevents problems like orphan records, which happen when a record in one table points to a missing or non-existent record in another. These orphan records can seriously undermine the trustworthiness of your data, leading to incorrect reports and poor decisions. That's why regularly checking for referential integrity is so important. It helps preserve the overall structure of the database and ensures that the data remains reliable. By running these integrity checks, we support accurate analytics and reporting, which are crucial for making informed business decisions. Next, we'll look at some practical ways to test these relationships and catch issues early on. An orphan record happens when a child table points to a parent record that doesn't exist, which can cause inconsistencies and errors when analyzing data. To catch these, we use SQL queries with a left join, which helps us find child records that don't have a matching parent. This method is really useful because it lets us identify and fix these orphan records, keeping the data reliable and accurate. For example, if you have an orders table linked to a customers table, an orphan order would be one that refers to a customer ID not found in the customers table. Detecting these ensures the relationships in your database remain intact, preventing problems down the line in reporting or decision-making. Next, we'll look at how to test entities more broadly to make sure all parts of the data structure are sound. Now that we've looked at how to ensure data integrity through entity testing and detecting issues like null primary keys and orphan records, let's move on to transformation testing. This type of testing focuses on verifying that the data transformations applied during the ETL process are correct. It involves checking that data is accurately converted, aggregated, or calculated as expected when moving from source to target systems. For example, if a date format is changed or Sales figures are summed across regions. Transformation testing ensures these operations produce the right results without introducing errors or data loss. This step is crucial because even if the data itself is valid, incorrect transformations can lead to inaccurate reporting and decision-making. Next, we'll explore specific scenarios and methods for performing these checks effectively. When we talk about validating data transformations, the main goal is to make sure that all the calculations, aggregations, and lookups happening during the ETL process are done correctly. If there's a mistake here, it can cause the numbers to be off or the reports to show misleading results, which can lead to poor decisions. To catch these issues, we use a mix of automated tests that quickly scan for common errors and manual reviews, where a tester carefully checks whether the data matches what's expected. This combination helps ensure that the data we end up with is accurate and reliable, preventing problems that might otherwise go unnoticed in complex data workflows. Next, we'll dive into some specific hands-on testing examples to see how these validation steps work in practice. When we talk about aggregate validation in ETL testing, we're focusing on ensuring that total values and averages are calculated correctly as data moves from the source systems into the data warehouse. For example, using SQL's sum function, we can add up all sales amounts in the source sales table to get a total. Then, by comparing this total to what's stored in the warehouse, we verify that the ETL process hasn't missed or duplicated any data. This step is crucial because even small errors in aggregation can lead to misleading reports or business decisions. Essentially, aggregate validation acts as a checkpoint that confirms the data warehouse reflects the true, accurate summary of the source data. This kind of testing helps catch issues like incomplete data loads, incorrect transformations, or calculation mistakes before they affect downstream analytics. Next, we'll move on to discussing how to detect null primary keys, which is another key aspect of data integrity in ETL. Now let's move on to regression testing. This type of testing is important whenever changes are made to the ETL processes or the data warehouse environment. The goal is to confirm that recent updates haven't introduced new errors or caused existing functionality to break. For example, if we modify a transformation rule or add a new data source, regression testing helps ensure that all previous data validations, like referential integrity and accurate aggregations, still hold true. It acts as a safety net, catching issues such as data mismatches or missing records that might have slipped in due to changes. By running a comprehensive suite of tests regularly, we maintain confidence in the overall data quality and reliability, which is crucial for making informed business decisions. Next, we'll explore specific techniques for regression testing in ETL workflows and how they fit into the broader testing strategy. Regression testing in ETL is crucial because every time we make changes or updates, there's a risk of introducing new errors that can affect data quality. To catch these issues early, we use a data comparison method, which means we carefully compare the data before and after the updates to ensure nothing unexpected has changed. This helps us catch any discrepancies that might have slipped through. By regularly performing regression testing, we support continuous improvement, making sure our data systems remain reliable over time. This is especially important in real-world data environments where accuracy and consistency are key for making informed decisions. Next, we'll build on this by looking at some practical examples of how to implement effective regression tests in your ETL workflows. Data difference detection plays a key role in making sure our datasets stay accurate by pinpointing any changes between versions. One common way to do this is by using the minus operator in SQL, which helps us find records that appear in one dataset but not the other, essentially highlighting missing or extra data points. This technique is especially useful in regression testing because it allows us to focus on specific discrepancies after data updates or transformations. By identifying exactly where data has changed or gone missing, we can investigate problems more efficiently and ensure that our data warehouse remains reliable and consistent over time. This approach complements the other testing methods we've discussed by providing a clear view of data differences and supporting continuous data quality assurance. Now that we've looked at regression testing and how SQL can help detect differences in datasets, let's move forward and explore the various types of ETL testing and the role SQL plays in these processes. Understanding these testing types is key to ensuring data accuracy and reliability throughout the ETL lifecycle. We'll cover how tests like source-to-target validation, transformation testing, and performance testing work together, and how SQL queries are used to verify that data is correctly extracted, transformed, and loaded without loss or corruption. This foundation will help us better grasp the hands-on scenarios coming up, where we'll see these concepts applied to real-world data warehouse environments. When working with ETL processes, one key challenge is ensuring that the data is accurate and reliable after it moves through the pipeline. Duplicate data testing helps us catch any repeated records that could skew reports or analyses, improving overall data quality. Completeness verification makes sure that every record we expect to be transferred from the source has actually made it into the target system, so nothing is missing. Transformation testing focuses on checking that any changes or calculations applied during the ETL process are done correctly, ensuring the data is accurate after manipulation. Lastly, entity testing looks at the structure of the data itself, verifying that tables and relationships remain intact and consistent. Together, these testing types help us catch common issues like data mismatches, missing records, or transformation errors, giving us confidence that the data warehouse reflects the true state of the source systems. Next, we'll explore some practical test scenarios to see how these concepts come to life in real ETL environments. When working with ETL processes, SQL queries are essential tools for testing different aspects of data quality and integrity. For duplicate data testing, SQL helps us locate and handle repeated records, which can cause inaccuracies in reporting or analysis. Completeness testing uses SQL to verify that all expected data has been successfully transferred between systems, ensuring no records are missing. When it comes to transformation testing, CQL allows us to check that data changes follow the defined business rules, confirming that the transformation logic is correctly applied. Lastly, entity validation with SQL helps identify structural issues like primary keys that are null, which could lead to problems with data relationships and integrity. These testing approaches give us confidence that the data we rely on is accurate, complete, and well-structured, which is critical for effective decision-making in any data warehouse environment. Now that we've covered the different types of ETL testing and how SQL helps us detect issues like duplicates and missing records, let's move into some hands-on exercises. This is where you get to apply those concepts directly, testing real data scenarios to spot errors, such as data mismatches, transformation mistakes, or incomplete transfers. These exercises will help you practice verifying data accuracy and quality in a way that mirrors what happens in actual data warehouse environments. By working through these tests, you'll build confidence in identifying common ETL challenges and using the right testing techniques to ensure reliable, trustworthy data. Next, we'll dive into specific test scenarios that reinforce these skills and show you practical approaches to ETL validation. In this exercise, we focus on understanding the overall structure of our data and spotting any unusual patterns that might indicate issues. First, we check the number of rows coming from each source system. This helps us catch any sources that might be missing data or unexpectedly showing very low counts, which could signal a problem in the data extraction. or transfer process. Next, we look closely at key columns where null values should not appear, like primary keys or unique identifiers. Identifying any nulls here is critical because they can cause errors downstream and affect data integrity. By tracking these counts early, we can quickly pinpoint sources that need further investigation before moving on to more detailed testing. This approach lays a solid foundation to ensure that the data we work with is complete and reliable, which is essential for accurate reporting and analysis. Moving forward, we'll continue to build on this by exploring additional testing methods that help validate data quality throughout the ETL process. When we look at row counts by source, the goal is to check how much data is coming in from each system. Using SQL queries, we can quickly see if any source has an unexpectedly low or even zero count of records. This is important because if a source isn't sending the right amount of data, it could mean there's a problem with data extraction or transfer. For example, if a sales system usually sends thousands of records daily but suddenly shows 0 rows, that's a red flag. By identifying these anomalies early, we ensure that all expected data is fully ingested, which helps maintain accuracy and reliability downstream. It also points us toward potential data flow issues, such as broken connections, failed jobs, or source system outages, so we can investigate and fix them quickly. This step is foundational in ETL testing because completeness is critical before we move on to transformations or quality checks. Next, we'll explore how to assess null values in key columns, which helps us understand data quality from another angle. Thanks for following along. Next, we focus on checking the null rate in key columns, which is crucial for maintaining data integrity. Key columns, like ordered, uniquely identify records, so any missing values here can cause serious problems in analysis or reporting. By running SQL queries, we can count how many nulls appear in these important fields and track these counts over time. This helps us spot issues early and ensure the data is complete and reliable. If we find null values where there shouldn't be any, it signals a problem that needs fixing, whether that's in the source system, during data extraction, or within the transformation process. Addressing these gaps is essential to maintain trust in our data and to make sure downstream processes work correctly. Up next, we'll look at how to interpret these results and move toward resolving any data quality issues uncovered. Thank you for staying with me so far. Now let's focus on identifying and correcting invalid data formats and domain value errors, which is a critical step in ensuring our data is reliable. When data doesn't match the expected format, like dates entered as text or numbers stored as strings, it can cause problems downstream in reports or analytics. Similarly, domain value errors happen when data falls outside the acceptable range, such as a product category that doesn't exist or a status code that's invalid. By using targeted SQL queries, we can detect these issues by checking if data entries conform to the defined standards and flagging any anomalies. This process helps maintain high data integrity, ensuring that the data we work with is accurate and usable for decision-making. It's an essential part of ETL testing because without clean, valid data, the entire data warehouse can be compromised. Next, we'll move on to the hands-on lab exercises to apply these concepts in practice. In this task, we focus on identifying email addresses that don't follow the correct format, which is a common data quality issue. Using SQL queries, we count how many email records have problems and pull a sample of these to understand the patterns. The most frequent errors we see are missing the symbol or the domain part, like the .com or .org after the. These mistakes can seriously affect communication efforts, especially in marketing, because emails won't reach the intended recipients. By pinpointing these invalid entries, we can generate actionable insights to correct the data, either by cleansing it or flagging it for review. This step is crucial for improving the overall quality of our data, ensuring that downstream processes rely on accurate and usable information. Next, we'll look at how to handle domain value errors and other data validity issues to further enhance data reliability. In this task, we focus on identifying and fixing incorrect country codes within our data. We use SQL join operations to compare our data set against a trusted reference table containing valid country codes. This helps us spot entries that don't match any known country, which could be due to typos or outdated codes. Correcting these ensures our geographical data is consistent and reliable, which is crucial for accurate reporting and analysis. It also helps us meet global compliance standards, as many regulations require precise country-level data. By catching these mismatches early, we reduce errors that could affect business decisions or regulatory audits, keeping our data trustworthy and aligned with recognized standards. Next, we'll look at how to handle invalid email formats to further improve data quality. Consistency is key when working with ETL processes, especially to keep data accurate and reliable. One common challenge is dealing with duplicate records or uniqueness violations, which can distort analysis and decision-making. By using SQL queries, we can pinpoint these duplicates, whether they're simple repeats of the same record or more complex cases like composite duplicates, where multiple fields combine to create duplication or fact duplication, which can affect transactional data. It's important to regularly test and monitor these issues to maintain a consistent state in our datasets. When duplicates are found, refining our data validation and cleansing steps helps prevent them from slipping through. This ongoing attention ensures that the data we rely on remains trustworthy and supports sound business insights. Next, we'll explore how to implement these testing strategies effectively in your ETL workflows. When working with customer data, duplicates can cause real headaches, like skewed reports or inaccurate customer insights. To spot these duplicates, we often use composite keys, which means combining fields like first name, last name, and date of birth to identify records that might actually represent the same person. Using SQL's group by function with these composite keys helps us find groups of records that look alike. But it's important to dig a little deeper by checking other fields too, like email or phone number, so we don't mistakenly flag unique customers as duplicates. This investigation helps reduce false positives and improves the overall quality of our data. Addressing these duplicates is crucial because they can introduce errors further down the line, affecting everything from marketing efforts to customer service. By carefully removing or merging duplicates, we refine our data models and ensure the information we rely on is accurate and trustworthy. This step is a key part of maintaining data integrity in any ETL process, helping us build a solid foundation for analysis and decision-making. Next, we'll move on to discussing how to handle data that doesn't match expected formats or reference values. When working with fact tables in an ETL process, it's crucial to identify any duplicate entries, since these can cause inaccuracies in your analytics and reports. One effective way to spot duplicates is by using SQL's group by clause on key fields like order ID and line number, which helps reveal repeated facts. Duplicates can lead to inflated metrics or skewed results, so understanding their impact is important for maintaining data integrity. To avoid these issues, it's best to design your ETL jobs to be idempotent, meaning that running them multiple times won't create duplicate data. This often involves implementing checks before inserting new records and handling updates carefully. Additionally, after the data is loaded, thorough validation procedures should be in place to catch any remaining duplication problems, ensuring overall data hygiene and reliability. This approach helps keep your data warehouse clean and your reports trustworthy. Maintaining referential integrity is crucial to ensure that all relationships between tables remain accurate and valid throughout the ETL process. One common issue we need to watch for is orphan records. These happen when a child record references a parent record that doesn't exist, which can lead to misleading or incomplete data. To catch these, We use SQL queries to find unmatched keys, such as foreign keys without corresponding primary keys. Another challenge is missing dimension data, which can affect reporting accuracy by leaving gaps in our datasets. By regularly running checks and validations during ETL, we can identify and fix these inconsistencies early. Strategies like enforcing foreign key constraints, using lookup validations, and scheduling continuous integrity checks help keep the data reliable. This approach not only prevents errors, but also supports better analytics and decision-making by ensuring that all related data stays connected as intended. When dealing with data in a warehouse, it's important to ensure that every order item is linked to a valid parent order. Sometimes we encounter what's called orphan order items. These are records in the child table that don't have a matching entry in the parent order table. To find these, we can use SQL queries with a left join, which helps us identify child records that lack corresponding parents by checking where the joined parent data is missing. This is crucial because orphan records can distort reports, cause inaccurate analysis, and undermine overall data integrity. Once identified, we need to correct these inconsistencies, either by updating the orphan items to link them correctly or by removing invalid records. Beyond fixing existing issues, it's also essential to establish preventive measures, like enforcing referential integrity constraints and thorough validation during ETL processes, to minimize the chance of orphan records occurring in the future. This approach helps maintain clean, reliable data that supports accurate decision-making. Moving forward, we'll explore how to apply these principles practically and continue strengthening data quality across the system. When working with data warehouses, it's important to ensure that every fact record, like a sales transaction, properly links to its related dimension data, such as customer or product details. If a fact row points to a dimension that doesn't exist, it can cause issues with reporting accuracy and create inconsistencies in your analytics. To uncover these gaps, we often use a SQL left join between the fact and dimension tables. This lets us spot any fact entries that don't have matching dimension records on the other side. Missing dimension data affects both the integrity of your dataset and the reliability of any insights drawn from it. By regularly performing these checks, you can catch these mismatches early and keep your data system strong and trustworthy. Next, we'll take a closer look at how to handle these missing dimensions effectively to maintain clean and consistent data flows. When we talk about completeness testing, the main goal is to make sure that every single record we expect to transfer from the staging area to the target system actually makes it there. This helps us catch any missing data early on, which is crucial because even a few lost records can cause big discrepancies in reports and decision-making. Think of it like moving files from one folder to another. If some files don't get copied over, the new folder won't be accurate or reliable. To prevent this, we use checks that compare record counts between the source and target systems, looking for any differences. These checks help us quickly identify gaps so they can be addressed before the data is used. Maintaining completeness ensures that our datasets stay trustworthy and supports better business insights. Next, we'll dive into how to handle these checks practically and what tools we can use to automate this process. To ensure data completeness during ETL, one effective method is to compare the total number of rows between the staging table and the target table. This helps us quickly spot if any records were missed or lost during the data transfer. By running simple SQL queries to count rows in both tables and then comparing these counts, we can detect discrepancies early on. For example, if the staging table has 10,000 rows but the target only shows 9,950, we know something went wrong in the process. Catching these issues at this stage prevents inaccurate reporting and builds confidence in the data migration. This approach is a fundamental step in validating that all expected data has successfully moved through the ETL pipeline. Next, we'll look at how to handle specific data mismatches that can occur within the records themselves. When working with data migrations, one common challenge is identifying keys that exist in the staging area but are missing in the target system. Using the SQL except clause is a straightforward way to find these discrepancies by comparing key columns between the two tables. Detecting these missing keys is essential because it helps prevent incomplete data transfers, which could lead to gaps in your reports or analysis. For example, if some customer IDs are present in the staging table but don't make it to the target, any downstream reporting relying on those customers would be inaccurate. By ensuring all relevant IDs are successfully transferred, you maintain data fidelity and support consistent, reliable insights across systems. Proactively monitoring for missing keys also reduces the risk of data loss and improves overall data quality, making your ETL process more robust and trustworthy. Next, we'll explore how to verify completeness by comparing row counts, which gives another layer of confidence in your data migration efforts. When working with data transformations, it's important to make sure that every step, whether it's lookups, aggregations, or applying business rules, is done correctly to keep the data consistent and reliable. If there are errors during transformation, it can lead to inaccurate analysis, which might cause wrong decisions down the line. One way to prevent this is by using SQL queries to check that the data manipulations happening in the ETL pipeline are accurate. For example, you might verify that sums or counts match expected values after aggregation, or that lookup tables are correctly joined without missing or mismatched records. Additionally, implementing thorough testing to ensure that the business logic is properly reflected in the transformed data helps catch issues early. This approach makes sure the final data you use for reporting or analysis truly represents the source information in the way the business requires. Next, we'll look at how to apply these concepts practically with some hands-on testing scenarios. When working with product data and ETL processes, it's important to identify any product codes in the staging area that don't have matching entries in the dimension tables. We do this by performing a left join in SQL, which helps us find records that exist in the staging table but are missing from the dimension table. Once these unmatched product codes are highlighted, we apply specific transformation rules to capture and handle them appropriately. This step is crucial because any unmatched data can indicate gaps or errors in the data pipeline, so we set up alerts to flag these issues for timely review and cleanup. To manage these unmatched products effectively, we also propose strategies within the ETL workflow, such as assigning default values, routing records to error tables, or triggering manual interventions, all aimed at maintaining data quality and ensuring accurate reporting. This approach helps prevent downstream problems and keeps the data warehouse reliable for analysis. Next, we'll look into how transformation validations ensure data consistency during the ETL process. Next, we focus on aggregate reconciliation, which means comparing the total sales amounts recorded each day in both the staging and target tables using SQL queries. This helps us ensure that the sums match after the data has been transformed and loaded. It's important to run queries that group sales by date and then compare those totals side by side to catch any differences. We also need to double-check that the filters applied in these queries align exactly with the transformation logic used during processing, because any mismatch there could cause discrepancies. When we find differences in the daily totals, it often points to errors in the transformation step, such as incorrect calculations or missing data. Identifying these issues early allows us to report them clearly to the data engineers so they can investigate and fix the problems, ensuring the data we work with is accurate and trustworthy for reporting and analysis. When working with financial data, it's crucial to ensure that total price calculations are accurate and consistent. Here, we focus on comparing the total price fields stored in the system with the values calculated by adding the base price and tax. By running SQL queries, we can directly compare these amounts to identify any discrepancies. This step helps us confirm that the transformations applied during the ETL process are correctly implementing the pricing formula. If any mismatches are found, they need to be corrected promptly to maintain reliable financial reporting. To prevent future issues, it's also important to set up automated checks that verify these calculations during each data load, ensuring ongoing consistency and accuracy in the data warehouse. This way, we can trust the total price figures used in analysis and decision-making. When working with ETL processes, handling incremental loads and slowly changing dimensions is crucial to maintaining accurate and trustworthy data. Incremental loads help us update only the new or changed records, which makes the process more efficient and reduces the risk of overwriting important historical data. Slowly changing dimensions, or SCDs, are techniques used to track changes in dimensional data over time, like if a customer moves to a new address or changes their name. This way, we can keep a history of those changes without losing past information. To do this well, the ETL process needs to detect these changes precisely, often using change detection methods like timestamps or version numbers, so that only the affected records get updated. This careful approach ensures that the data warehouse reflects both current and historical states accurately, supporting better analysis and decision-making. Next, we'll look at practical examples of how these concepts are implemented and tested in real ETL workflows. To identify which customer records have changed, we compare their current data with the previous version using hash values. This method helps us quickly spot any differences without checking each attribute manually. We do this by running SQL queries that join the staging area where new data arrives, with the dimension tables that store existing customer information, matching them on unique business keys like customer IDs. When the hashes don't match, it means some attribute has been updated, signaling a change that our ETL process needs to handle carefully. Whether that means inserting a new record, updating an existing one, or preserving historical data as part of slowly changing dimensions. Documenting these differences is essential because it lets us review what's changed and refine the ETL logic to ensure data accuracy and consistency over time. This approach helps maintain reliable customer data while avoiding unnecessary overwrites or missed updates. In this task, we focus on ensuring that the current rows in a slowly changing dimension type 2 or SCD2 remain unique. SCD2 is a method used in data warehousing to keep track of historical changes by storing multiple versions of a record over time, while clearly identifying which version is the current one. The challenge here is to validate that for each business key, think of it like a unique customer ID or product code, there is only one active or current record at any given time. To do this, we use SQL queries that scan the data to find any business keys that mistakenly have more than one current version, which would signal a data quality issue. Catching these duplicates is important because having multiple current rows can lead to inaccurate reporting and confusion in decision-making. This step builds on our previous work identifying changed rows and understanding how updates are tracked, and it helps ensure the integrity of our historical data while maintaining reliable, up-to-date information for analysis. Next, we'll look at how to handle these identified duplicates effectively. Regression testing is essential whenever we make changes to the ETL process to ensure those changes don't unintentionally break or alter existing data outputs. The main goal here is to confirm that the data remains accurate and consistent after any modifications. To do this, we typically compare datasets from before and after the ETL changes, looking for any differences that shouldn't be there. SQL queries are very useful in this process because they allow us to pinpoint inconsistencies at a detailed level, such as mismatches in records or unexpected shifts in values. Think of it like making sure that after updating a recipe, the cake still tastes the same. Any deviation could mean something went wrong. This kind of testing helps us maintain trust in our data warehouse by catching errors early, ensuring the reliability of reports and analytics that depend on the ETL pipeline. Next, we'll explore how to handle incremental loads and slowly changing dimensions, which build on these concepts to manage evolving data over time. When working with large data sets in ETL processes, checking data integrity at the partition level helps us focus on specific segments without scanning the entire dataset. This means we can quickly spot any differences or mismatches in the data that might have occurred during extraction or transformation. For example, if one partition contains sales data for a particular month, running a partition-level diff allows us to verify that the ETL output matches the source data for that month alone. By isolating this, we can identify issues faster and troubleshoot more efficiently, rather than sifting through all the data at once. This targeted approach not only saves time but also improves the accuracy of our error detection, helping maintain reliable and consistent data within the pipeline. We'll look into how regression testing ensures that changes in ETL processes don't break existing data outputs. As we wrap up the lab, it's important to document everything we've found during our SQL checks and the anomalies we've uncovered. This means carefully logging the results so we have a clear record of any data mismatches, transformation errors, or missing data issues. Once these findings are documented, the next step is to classify each issue by severity, whether critical, high, medium, or low, so we know which problems need immediate attention and which can be addressed later. Finally, we propose prevention measures to avoid these issues in the future. This could involve adding constraints directly in the database, implementing validation earlier in the data pipeline, or setting up automated checks to catch problems as soon as they occur. These steps help maintain data quality and reliability, ensuring that the ETL process runs smoothly and that the data warehouse remains trustworthy. Next, we'll move on to our final slide, where we'll summarize the key takeaways from today's session. To keep our ETL process reliable and efficient, the next step is to convert the SQL checks we've developed into automated tests. This way, we can continuously validate data quality without manual effort, catching issues early as data moves through the pipeline. Planning how to integrate these automated checks directly into the ETL workflow is essential, so they run seamlessly during each data load or update. Now, I'd like to open the floor for any questions or concerns you might have. Feel free to share your thoughts or ask about specific challenges you've encountered. This is also a great opportunity to discuss any new ideas or strategies that could improve our testing approach and overall data integrity. Thank you all for participating and staying engaged throughout the session. We've covered essential concepts around ETL issues, such as common challenges like data mismatches and transformation errors, as well as the importance of testing different aspects including regression and partition-level validations. By understanding these testing approaches and hands-on tasks, you're now better equipped to ensure data accuracy and maintain the reliability of data warehouses in real-world projects. If you have any questions or need further clarification, feel free to reach out later. I appreciate your time and attention today.